So using rational expressions, we're going to use a rule that changes it from exponential form to radical form, or from radical form to exponential form. And a radical can be written as an exponent, saying the nth root of a is equal to a raised to the 1 over n. Okay, so that root goes in the denominator is 1 over that root. So 216 raised to the 1/3 can be written as the cube root of 216. That denominator becomes the root there, and then the cube root of 216 is 6. And this one, what I can do is I can change the 7 raised to the 1/2 as the square root of 7 times the square root of 7. And now, because the radicals are the same, they're both square roots, I am allowed to multiply them, and that becomes the square root of 49, and then the square root of 49 becomes 7. So that's how it's simplified. One more here. 5 raised to the 1/4, well, that's going to mean the 4th root of 5, and that's multiplied with the 4th root of 125. And now, because they're both 4th roots, I can multiply those, and that becomes 5 times 125, which is 625. And the 4th root of 625 becomes 5. Okay, so we'll go on to the next ones. And what these cover is when it's not only 1 over a denominator, but it has a numerator in the exponent as well. So I'm going to write a new rule here. A raised to the m over n is going to be equal to the nth root of a raised to the m. You can also write that as the nth root of a in parentheses raised to the m. Okay, either one of these will work. And basically what you need to know is that the denominator here goes to the root. The numerator will be the exponent. So in this one, I have x raised to the 3 over 7. That means my denominator is going to be the root. That's the 7th root of x to the 3rd. I could also write that as the 7th root of x in parentheses raised to the 3rd. When it's a decimal, this is negative 3.5 if you can't see that. That's a decimal there. You have to change it to a fraction first. So the way I'm going to change that to a fraction, negative 3.5 over 1, I'm going to make that negative 35. So what I did is I multiplied that by 10, but I also need to multiply the numerator by 10, and then reduce it, and that becomes reduced by 5, negative 7 over 2. So I have y raised to the negative 7 over 2. And to make that exponent a positive, remember we're going to move it to the denominator, so that's 1 over y raised to the positive 7 over 2. And I'm going to come down here, and I have 1 over the square root of y to the 7th. And I can't leave that radical in the denominator, so I'm going to simplify it, and I can bring a y to the 3rd out, and I'm left with square root of y. I'm left with 1y on the inside, and I still have a radical in the denominator, so to rationalize that, I'm going to multiply by the square root of y. So I have the square root of y over y to the 3rd times the square root of y squared, and the square root of y squared then becomes y, and y to the 3rd times y is y to the 4th. And that's the simplified form. A little bit more intricate when you start getting radicals in the denominators and the negative exponents, but you can still use all the rules that we know. Okay, in this next one, I have exponential form, and I'm going to write it in I'm giving it in radical form, and I'm writing it in exponential form. So my root here, because it's not shown, that means it's a square root. So that means my denominator is going to be a 2. And my numerator comes from the exponent, which is 5. So I have a raised to the 5 over 2. And in this one, even though the exponent's on the outside, it's the same thing. That's going to be my numerator, b raised to the 3 over, and my denominator comes from the root 3 over 5. I'm saying quickly, there are going to be times where we use the exponent rules that we did at the very beginning of this unit, the very first thing after break. So I'm going to refresh your memory on those using these rational exponents. Because my bases are the same here, I can add the exponents, and 1/3 plus 2/3. Remember, to add fractions, you have to have a common denominator. So that's going to be 3/3, which is just 8 to the first. Power to a power, you can multiply the exponents, so that's 5 raised to the 1/2 times 4. And remember, multiplying, you don't need a common denominator, you just multiply straight across. 4 over 1 times 1 over 2 becomes 4 over 2, which is 2, which then is 25. This becomes 4 raised to the 1/2 times 5 raised to the 1/2, because this exponent, remember, I think of it as distributing to the exponents, though. You got to say to the exponents, and both those exponents on each of those is 1/2. And that is going to make the square root of 4 times the square root of 5, but the square root of 4 can simplify to 2, so I have 2 times the square root of 5. Negative exponent, we already talked about this one. That's going to move to the denominator. And then 9 raised to the 1/2, well, that becomes the square root of 9, and the square root of 9 is 3, so it simplifies to 1/3. When you're dividing, you subtract the exponents. 3 over 2 minus 1 over 2, so that's going to be 2 over 2, so this is 7 to the first, which is just 7. And a power of a quotient, remember that power, that exponent, goes to both numerator and denominator to the exponent, so it's 5 raised to the 1/3 over 27 raised to the 1/3. And I can change that to the cube root of 5 over the cube root of 27. And by now you should be familiar with the cube root of 27 is 3. And that doesn't need to be rationalized anymore. Those are the simplified form. So we can use these rules. I went through them a little quickly, but just refreshing your memory on these rules. And we can still use them even though the exponents are fractions. So here, be careful to pay attention that these are different radicals, so I can't simplify this here. I can't simplify those x's where they are now because they're different radicals. So if you can't do anything with it, try to change the form. So it's in radical form. Let me change it to exponential, and I have x raised to the 3 over 4 over x raised to the 2 over 8. And now, because these are both x's, I am able to simplify, and I'm going to subtract the exponents. So I have 3 over 4 minus 2 over 8. And remember, to add and subtract, I need a common denominator. Well, my denominator, or my 2 over 8, can reduce to 1 over 4. And then that becomes 2 over 4. And x raised to the 1/2. That would be an okay answer, or you can put it in radical form, and that would be the square root of x. In class, we did this one 2 methods. I'm only going to do 1 method. If you'd like the other method, you can check out the book and look at the book. It shows the other method as well. But either way, I'm going to have to change this exponent to a fraction. So I have negative 2.5 over 1. If I multiply both by 10, that's negative 25 over 10, and that's going to reduce to negative 5 over 2. So I have 16 raised to the negative 5 over 2. Okay, and because it's a negative, let me go ahead and take care of that, and I'm going to make it a positive by moving it to the denominator. Now notice my exponent still says 5 over 2, but it just becomes a positive when I move it. And now I'm going to change it to radical form, so it's the square root of 16 raised to the 5th. Now I could write it like this, or I could put that in parentheses and write it like that. It basically, whichever one's going to make it easier is the one you want to do. And since I see I can take the square root of 16, I'm going to go ahead and do that first. So we use the parentheses. And so I have the square root of 16 is 4. And then 4 to the 5th becomes 1024, 1024. Okay, so in this one, again, the book has another method you can use by changing the base, but I'm just going to use the changing it to radical form. So if I change this to radical form, it's going to be the 5th root of 32 raised to the 4th. And the majority of the time, I'm going to put the exponent on the outside, like that. The 5th root of negative 32, well, it's a negative, but understand that I am able to do that because it is an odd root. When it's odd, I am allowed to take that radical. So that is a negative 2. 5th root of negative 32 is negative 2 raised to the 4th. And when I raise a negative number to an even power, that becomes positive. So that's positive 16. Okay, so this is where we left off in the notes in class, and most likely, at least. And when I have all of these things being raised to an exponent, it's really each of those items. I'm going to take this exponent and distribute to each thing inside. So I have negative 8 raised to the 2/3. Don't forget about that coefficient. And that's being multiplied with x, and it's going to be raised to the 2/3. And then the square root of xy raised to the 2/3. And what causes some trouble here is this square root. And what I'm going to do in order to be able to raise that to the 2/3, I'm going to change that to exponential form. Because if that was xy raised to something, I would be able to do my operations with those operations with those two exponents. So as I'm doing it, I'm going to simplify that into a exponential form. So I have negative 8 raised to the 2/3 first, and I'm going to write that as the cube root of negative 8 squared times, I'm going to change this to the cube root of x squared, and then this is xy raised to the 1/2, that's the square root of x, and then that's being raised to the 2/3. Hope I could squeeze that in there. So this last part, I'm going to simplify that. I'm going to leave everything the same right now. Cube root of negative 8 squared times cube root of x squared times, and this is going to be xy raised to the 1/2, and I'm going to multiply that with 2/3 because that's power to a power, so I multiply these two. So that's going to become, again, I'm going to leave everything the same for right now. And that's going to become xy raised to the 2/6, which reduces to 1/3. And because it's 1/3, that should be squared still. I'm going to change that to the cube root. And it's the cube root of xy. And now I can simplify some more. So the cube root of -8 is -2, -2 squared. And what I can do here, because they're both cube roots, I can multiply them together, and x squared times x becomes x to the third. And now -2 raised to the second, or squared, becomes 4. The cube root of x cubed is x, and I still have that cube root of y on the inside, and that's the simplified form. I'm going to go ahead and move the next one to the next page. And again, I have a power of a product here, and what I'm going to do is this exponent is going to go to each term inside that parentheses, so that's 16 raised to the 3/4, and then y times y raised to the -8th raised to the 3/4. So 16 raised to the 3/4, I can simplify that if I change it to radical form. That's the 4th root of 16 cubed. And what I do with these two exponents, power to a power, I'm going to multiply, and that's -8 times 3/4. Let me do a little side work here so I don't have to write it every time. When I multiply, that's going to become -24/4, which reduces to -6. So I have the 4th root of 16 cubed times y raised to the, and that reduced to -6. So the 4th root of 16 is 2. And I'm going to make this exponent a positive, so I'm going to move it to the denominator. And then 2 cubed is 8, so I have 8 over y to the 6th, and that is my simplified form. Alright, here's some U-Try questions. Go ahead and make sure you attempt these and do your best on them before you come to class so that we have a good idea of what's going on. Okay? And that's it. No joke today. I'm just going to get this out as soon as possible. They've been bad anyway, so sorry about that. I'll get some better ones. Maybe.